If these minus are multiplied by a proper sign, plus, minus, minus, plus, alternative, positive, negative, then we are going to get the cofactors. If determinant of A is equal to 0, then it is called a singular matrix. On the other hand, if determinant of A is not equal to 0, then it is called the non-singular matrix. According to property, if all the elements in a row or column are zeros, then the value of a determinant is also 0. Hello dear students, welcome to this session of Mathematical Foundation class. I am Mr. Niranjan, Faculty, Department of Computer Science, Vidhyaashram First Grade College, the Temple of Excellence. Today in this session, I am going to discuss very important concept, that is adjoint of a square matrix. Once if you know how to find the adjoint of a square matrix, then it is very easy to find the inverse of a square matrix. Now, before going to the adjoint of a square matrix, let us know regarding the minors and cofactors of a matrix. Now, let me discuss with the minors and cofactors of a square matrix. Now, minors and cofactors of a square matrix. First of all, it is possible to find only for a square matrix the minors and the cofactors. Now, the minors of an element, the minor of an element Aij of a determinant is obtained by deleting its ith row and jth column, by eliminating ith row and jth column in which the element Aij lies. If the minors are multiplied by the proper sign, then we will get the cofactors. So, let us consider an example. Let A is equal to a matrix A is equal to A11, A12, A21, A22. Now, the determinant of this matrix is determinant of A is determinant A is equal to determinant A11, A12, A21, A22. Now, what is the minor? Minor of A11 is just delete the row and column containing A11. So, here A11, A12, A21, A22. The minor of A11 is just delete this. What is left over is A22. So, A22 is the minor. So, that means the minor of A11 is A22 is the minor of A11. Similarly, minor of A12, just delete the row and column containing A12. What we will get? A21. A21 is the minor. Similarly, for the second row, minor of A21 is delete this row and column containing A1. This is A21, this is gone. What is left over is A12. And finally, the minor of the last element A22, just delete this row and column containing A22, then what you will get? A11. This is the minor. So, this is how we are going to multiply the minors. If these minors are multiplied by a proper sign, plus, minus, minus, plus, alternative, positive, negative, then we are going to get the cofactors. If the minors are multiplied by a proper sign, we are going to get the cofactors of a matrix. So, here minors are nothing but deleting the row and column containing that particular element. So, if the minors are multiplied by a proper sign, then we are going to get the cofactor of that particular element. And the matrix which we are going to get is called as the cofactor matrix. Now, let us by knowing this, let us know regarding the adjoint of a square matrix. The adjoint of a square matrix A is equal to Aij of order m cross n, that is m into n, is defined as the transpose of the matrix A is called the adjoint. So, the adjoint of a square matrix is defined as the transpose of the cofactor matrix. The transpose of the cofactor matrix is called the adjoint and it is denoted as Adj. The adjoint of A is denoted as adjoint of A is equal to C dash. What is C dash here? C dash is called the transpose of the cofactor matrix. So, in general, just find out the cofactor matrix and transpose it. The transpose of the cofactor matrix will give the adjoint of the square matrix. So, the adjoint of a square matrix A of the form Aij is given by adjoint of A is equal to C dash. Now, let us take an example. If A is equal to 2, 3, 1, 4, find the adjoint of A. Now, just find out the adjoint of this. So, determinant of A is equal to determinant 2, 3, 1, 4. Find out the cofactors for this. As I told, if the minors are multiplied by the proper sign, then we are going to get the cofactors. The signs are plus, minus, minus, plus. Write down the cofactor. cofactor of first element 2 is equal to, delete this row containing 2 and column containing 2. This 2, 3 and 2 1 is gone. What is left over is 4. So this is gone. 4 is the cofactor of 2. Similarly, cofactor of 3 is, it is minus, delete row containing 3, this 3 and this is gone. What is left over is minus 1. Similarly, the cofactor for the second row, cofactor of 1 is equal to, it is negative sign minus, this row and column is deleted, we will get minus 3, and cofactor of the last element 4 is equal to, delete this row containing 4 and column containing 4, this is gone. What is left over is 2. So that's it. See here. So the cofactor of 2 is, just delete the row and column containing 2. This is gone. What is left is 4. Similarly, cofactor of 4 is equal to, this row and column is gone. So cofactor of 3 is equal to 1. So it is multiplied by negative sign. Similarly, the cofactor for the second row. So cofactor for all the elements in second row. First take 1. Cofactor of 1 is equal to minus, this row and column is deleted, 3. And cofactor of 4 is equal to, this row and column is deleted, you will get 2. So therefore, the cofactor matrix C is equal to, what are the cofactors in the first row? 4, 1. In the second row, minus 3 and 4, minus 1, minus 3 and 2. So therefore, the adjoint of this is denoted as, adjoint of A is equal to C dash, the transpose of this, that is 4, minus 1, minus 3 and 2. This is the adjoint. So the adjoint of this is given by ADJ is equal to 4, minus 3, minus 1 and 2. This is for 3 marks or 5 marks. Usually, you may expect this type of question for 2 marks or 3 marks. Suppose if it is for 1 mark, straight away we can write the adjoint. Adjoint of A is equal to, just very simple concept, interchanging the diagonals. 2 and 4 can be written as 4 and 2, and changing the signs for the secondary diagonal elements. Plus 3 can be written as minus 3 and plus 1 becomes minus 1. That's it. This is for 1 mark is concerned. So interchange the diagonal elements, interchanging the principal diagonal elements and changing the signs for the secondary diagonal elements will give the adjoincy 4, minus 3, minus 1 and 2. So if you do this much, you will get 3 or 4 marks or 2 marks sometimes. This is for 1 mark is concerned. Now you got an idea how to find the adjoint. Now let me take one more problem. Now A is any square matrix of order n. Their adjoint, then A into adjoint of A is equal to, adjoint of A is equal to determinant of A into I. So if A is any square matrix, then the adjoint of A into A is equal to determinant of A into A. That is, any matrix into adjoint is always equal to adjoint of A into matrix A is equal to determinant of A into I. This is the property. A into adjoint of A is equal to adjoint of A. That is also equal to determinant of A into I, where I is an identity matrix of same order. So for any square matrix of order n cross n, adjoint of A is always equal to, that is, determinant of A to the power of n minus 1. So for any square matrix of order n cross n, the determinant of adjoint of A is equal to determinant of A to the power of n minus 1. Determinant of A to the power of n minus 1. Suppose if A is equal to A11, A12, A21, A22, then the adjoint of this is denoted as, in general, the just interchanging the diagonals. So interchanging the principal diagonal elements, A11, A22 can be written as A22, A11, and changing the signs for the secondary diagonals, that is minus A12 and minus A21. Interchanging the principal diagonal elements and changing the signs for the secondary diagonal will give the adjoint by direct method. Now let us come to the problem. Now let us take a very important type problem of order 3 rows and 3 columns. This is very important type problem. You may expect this type of question for 7 marks. This is 7 mark question, very important. So if A is equal to minus 2, 2, 1, 4, 1, 2, 3, 2, minus 1, find the adjoint of this square matrix A. Now just find out the adjoint. Now determinant of A is equal to determinant of minus 2, 2, 1, 4, 1, 2, 3, 2, minus 1. And what are the signs for 3 rows 3 column matrices? It is alternative plus, minus and plus. plus, minus, plus, minus, plus, minus, plus, minus, and plus. So diagonals, principal diagonal and secondary diagonals are positive, remaining are all negative. Just find out the cofactors for each and every element. So find out the cofactors for all the 9 elements. Now let me take first cofactor of minus 2 is equal to, just let me explain one problem in detail, then I will go to the shortcut. Now the cofactor of minus 2 is equal to, delete this row and column containing 2. What is left over is 1, 2, 2, minus 1. So this is reduces to 2 rows to column. Simplify. 1 into minus 1 is minus 1. Minus 2 to the 4. This is equal to minus 5. Similarly, cofactor for a second element 2 is equal to, what is the sign? It is minus. Delete the row and containing 2. This row and this column and row is gone. 4, 2, 3, minus 1. 4, 2, 3, minus 1. This is minus. 4 ones are 4, minus 4. Minus 3 twos are 6. Minus of minus 10, that's equal to plus 10. Similarly, cofactor of 1 is equal to, what is the sign? It is positive. This row and column is gone. What is left over is 4, 1, 3 and 2. This is equal to 4 2s are 8 minus 3, that's equal to 5. These are the cofactors for the first row. Listen. So the signs are plus, minus, plus, minus, plus, minus, plus, minus, and plus. Now first take first element cofactor of minus 2. Delete this row and column containing 2. What is left over is 1, 2, 2, minus 1. Simplify. Expand 2 rows to column determinant. Minus 1, minus 2 to 4. Minus 1, minus 4 is minus 5. Similarly, for the second element 2, the cofactor, just delete the elements containing this row and column. So this is gone, this is gone. What is left is 4, 2, 3, minus 1. 4, 2, 3, minus 1. 4 ones are 4, minus 3 twos are 6. Minus 6 minus 4 is minus 10. Minus of minus is plus 10. Similarly, for this element 1, delete this row and column. What is left over is 4, 1, 3, 2. 4, 1, 3, 2. 4 twos are 8 minus 3, that's equal to 5. This is for first row. Similarly, find out the cofactors for the second row. Now let us come to the next row. Now I will write down the problem again. What is the problem? A is equal to, determinant of A is equal to determinant minus 2, 2, 1, minus 2, 2, 1, again 4, 1, 2, 4, 1, 2, and 3, 2, minus 1. So the signs are plus, minus, plus, minus, plus, minus, plus, minus, and plus, right? So diagonals are positive, remaining are all negative. Now let us write down the cofactors for the second row. Cofactor of 4 is equal to, it is minus, negative. Delete the row and column containing 4. This row and column is gone. What is left over is 2, 1, 2, minus 1. This is equal to minus 1 2s are 2, minus 2, minus of minus 2 is minus 4, minus into minus plus 4. Similarly, the cofactor for 1 is equal to, plus it is, this row column is gone, this row column, minus 1, minus 2, plus 1, 3 and minus 1. See, this row column is gone, minus 2, 1, 3. So this is equal to minus into minus, plus 2 ones are 2, minus 3, this is equal to minus 1. Similarly, the cofactor for 2, the sign is minus. This row and column is gone, this is gone, minus 2, plus 2, again 3 and 2. So this is gone, minus 2, plus 2, 3 and 2. So minus 2 2s are 4, minus 6. So that's equal to minus of minus 6 minus 4 is minus 10, minus into minus plus 10. Let me explain once again. See the cofactor for the second row. Cofactor of 4 is equal to, delete this row and column, 2, 1, 2 minus 1. Minus 2 is minus 4, minus into minus plus. Cofactor for this row and column is gone, minus 1, minus 2, 1, 3, minus 2, 1, 3, minus. So this is equal to minus into minus plus 2, minus 3 is equal to minus 1. Similarly, the cofactor for 2 is equal to, this row column is gone, minus 2, 2, 3, 2, minus 2, 2, 3, 2, minus 2 2s are 4, minus 6, minus 6 minus 4 is minus 10, minus into minus plus 10. Now, similarly for the last row, find out the cofactors for the last row. That is, cofactor of 3 is equal to, this row and column is gone, 2, 1, 1, 2. So 2 2s are 4 minus 1 is equal to 3. Similarly, the cofactor of 2 is equal to, what is the sign? It is negative, minus, this row column is gone, minus 2, 1, minus 2, 1, again 4 and 2. So this is equal to minus of 2 2s are 4, minus 4, minus 4, that's equal to minus of minus 8 is plus 8. And the last element, the cofactor of minus 1, I'll write here minus 1, it is plus, this row and column is deleted. What is left over is minus 2 plus 2, 4 and 1. So this is minus 2 minus 8, that's equal to minus 10. So these are the cofactors. Now therefore, the adjoint of this is given by, write down the first cofactor matrix. So therefore, the cofactor matrix C is equal to, write down the cofactors. In the first row, what we got? Minus 5, 10 and plus 5. Minus 5, 10 and plus 5. For the second row we got 4, minus 1 and 10. 4, minus 1 and 10. In the third row, we got 3, 8 and minus 10. 3, 8 and minus 10. So these are the cofactors. Therefore, the adjoint of this is given by C dash is equal to adjoint of A. Adjoint of A is equal to, transpose this, minus 5, 10 and 5, 4, minus 1 and 10 and 3, 8, minus 10. So these are the cofactor. These are the adjoint. Otherwise, straight away you put in the form of, instead of writing first row, second row, third row, you can put it in the form first column, second column, third column. Straight away you will get the adjoint. Any method. So if you put the elements in first row, second row, third row, transpose it, you will get the adjoint. Or if you put the elements in first column, second column, third column, that itself will give the adjoint. So this is how we are going to find the adjoint of a 3 rows, 3 column matrix. Hope you followed. Very, very important problem for 7 or 8 marks. Now let us know regarding next concept, singular matrix and non-singular matrix. This is also a very important concept. A square matrix A is said to be singular if determinant of A is equal to 0. If determinant of A is equal to 0, then it is called a singular matrix. On the other hand, if determinant of A is not equal to 0, then it is called the non-singular matrix. So let us discuss regarding the singular matrix. A square matrix A is said to be singular if determinant of A is equal to 0. Let us take an example. If A is equal to, matrix A is equal to 1, 2, 4, 8, then the determinant of this is 1, 2, 4, 8 is 1 into 8 is 8 minus 4 is 8, 8 minus 8 is equal to 0. Therefore, A is a singular matrix because determinant of A is equal to 0. Let me take one more example. Another example, B is equal to 3, 4, 2, 6. Now, the determinant of this is determinant is equal to 3, 2, 6, 4. Simplify this. 3 into 4 minus 6 into 2. 3 into 4 is 12 minus 12. 12 minus 12 is equal to 0. So, determinant of B is equal to 0. Therefore, B is a singular matrix. B is a singular matrix. B is a singular matrix. Right. So, a matrix A is said to be singular if its determinant value is equal to 0. If determinant of A is equal to 0, then it is called a singular matrix. Let me take one more example. C is equal to x, 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 x. Then what is this equal to? Determinant of C is determinant x, 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 x. That's equal to x into x is x square minus x square is equal to 0. This is also an example for a singular matrix. Now let us take 3 rows, 3 column matrix. If A is equal to 3, 2, minus 1, 4, 1, 5, 3, 2, minus 1, determinant of A is equal to 3, 2, minus 1, 4, 1, 5, 3, 2. So its value is equal to 0. If you observe carefully, since 2 rows are same, according to properties of determinant, if 2 rows, 2 columns are identical, then the value of a determinant is equal to 0. Here, first row and third row are same. Therefore, the value of determinant is 0. Since determinant of A is equal to 0, therefore, A is a singular matrix. Now, let me take one more example. If it is like this, if A is equal to another matrix 1, 2, 3, 4, 1, 3, 0, 0, 0. So, the value of this determinant is also equal to 0 because according to property, if all the elements in a row or column are zeros, then the value of a determinant is also 0. So this is determinant of A is equal to 0, therefore it is a singular matrix, right? Singular matrix. Now let us come to the next concept, that is a non-singular matrix. What is a non-singular matrix? So if determinant of A is not equal to 0, then it is called a non-singular matrix. If determinant of A is equal to 0, it is a singular matrix. If determinant of A is not equal to 0, then it is called a non-singular matrix. A square matrix A is said to be non-singular if determinant of A is not equal to 0. Let us take an example. If A is equal to 1, 2, 3, 4, determinant of A is 1, 2, 3, 4. 1 4s are 4, minus 3 to the 6, minus 2 not equal to 0. Therefore, A is a non-singular matrix because determinant of A is not equal to 0. Let us take one more example. B is equal to 1, 2, 4, 5. Yeah. Then the value of this determinant is 1, 2, 4, 5. So this is equal to 1 into 5 is 5, minus 4 into 2 is 8. This is equal to minus 3 not equal to 0. Therefore, this is also a non-singular matrix. Another example, if C is equal to minus 3, minus 2, 1 and 4. So what is this equal to? Determinant of C is equal to minus 3, minus 2, 1 and 4. Simplify, minus 12, minus into minus plus 2, that's equal to minus 10 not equal to 0. Therefore, this is also an example for a non-singular matrix. So, in general, if determinant of A is equal to 0, then it is called a singular matrix. If determinant of A is not equal to 0, then it is called a non-singular matrix. Now, so this is very important concept because in the next concept, we are going to find the inverse of a non-singular matrix. So, it is possible to find the inverse for a non-singular matrix, not for a singular matrix. So, that is why in the next concept, we are going to study regarding inverse of a non-singular matrix. Now, let us take some examples. This type of problems are very important. Solve for x if A is equal to 3, 2x minus 4, if this is a singular matrix. So, solve for x if A is equal to 3, 2x minus 4 is a singular matrix. Now, according to definition, what is given? Given that A is a singular matrix. A is a singular matrix. Singular matrix means determinant of A is equal to 0. That is, determinant of this 3, 2x and minus 4 is equal to 0. Simplify. 3 4s are 12, minus 2x is equal to 0. 3 into 4 is 12, minus 2 into x is 2x, minus 12 is equal to plus 2x, x is equal to minus 12 by 2, that's equal to minus 6. So, therefore, x is equal to minus 6. If you do this much, you will get 2 marks. So, very simple concept. What is given? Since A is a singular matrix means determinant of A is equal to 0. Equate to 0. 3 into 4 is minus 12. Minus 2x is equal to 0. 2x is equal to minus 12. X is equal to minus 12 by 2 is minus 6. Now, let us take next problem. So, if A is equal to 1, x2, 3, minus 1, 2, 0, 1, 3 is a singular matrix, find x. This is also important for 5 marks. Usually, you may get this type of questions for 5 marks. Very simple problem. See what is given? Given A is a singular matrix. A is a singular matrix means determinant of A is equal to 0. That is determinant of this 1, x, 2, 3, minus 1, 2, 0, 1, 3 is equal to 0. Expand with respect to first row, plus, minus and plus. 1 into minus 1 into 3 is minus 3, minus 1 into 2 is minus 2, minus x into this is gone, 3 into 3 is 9, minus 0, plus 2 into these 2 are gone, 1 into 3 is 3, minus into plus it is minus 1 into 0 is 0. Minus into minus plus 1 into 0 is 0, whatever it may be. So, this is 1 into minus 5, minus x into 9, plus 2 into 3 is equal to 0. Simplify this, that is minus 5, minus 9x, then plus 2 3s are 6 is equal to 0. So, what is this equal to? See, this is minus 9x, 6 minus 5 is plus 1 is equal to 0. Minus 9x is equal to minus 1. X is equal to minus 1 by minus 9. Therefore, minus and minus gets cancelled. X is equal to 1 by 9. That's it. Very simple. See here. So, expand with respect to first row. 1, this is gone. 1 into minus 3 is minus 3. Minus 2 minus x into this row and column is deleted. 3 3s are 9 minus 0 plus 2 into This row and column is gone. 3 into 1 is 3. Minus into plus minus. 1 into 0 is 0. Minus 3 minus 2 is minus 5. Minus x into 9 minus 0 is 9. 3 plus 0 is 3. So minus 5 minus 9x. 2 3s are 6. So minus 9x. 6 plus 6 minus 5 is plus 1. Minus 9x is equal to minus 1. Therefore, x is equal to minus 1 by minus 9 means x is equal to 1 by 9. That's all. So if you do this much, definitely you will get 5 marks. Very easy to get 5 marks in this. Now let us come to the next problem. This is also important for 7 marks. Usually you will get this type of question for 7 marks. If A is equal to 1, 2, 3, 4, then prove that A into adjoint of A is equal to adjoint of A into A. Now just find out the adjoint and multiply with the matrix. First, what is determinant of A? Determinant of A is equal to 1, 2, 3, 4. Now just find out the adjoint. So as I told, the easiest method to find the adjoint is adjoint of A is equal to interchange the diagonals, interchanging the diagonals. So 1, 4 can be written as 4 and 1, and changing the signs for the secondary diagonals, minus 2 and minus 3. That's it. So interchange the principal diagonal elements and changing the signs for the secondary diagonal elements. Now take LHS. What is LHS? A into adjoint of A. What is A? A is the given matrix 1, 2, 3, 4, and adjoint of A is equal to 4, minus 2, minus 3 and 1. This is equal to matrix multiplication, multiplication of matrix. First row, first column, second column. So 1 into 4 is 4, again minus 2 into 3 is 6. Same row, second column, 1 into minus 2 is minus 2 plus 2 into 1 is 2. Again second row, first column, second column, 3 into 4 is 12. Minus 4 into 3 is 12, 12 minus 12. Again same row, last column, 3 into 2 is 6, minus 6 plus 4 into 1 is 4. So what is this equal to? This is equal to 4 minus 6 is minus 2, minus 2 plus 2 gets cancelled, 0, 12 minus 12 is 0, minus 6 plus 4 is minus 2. This is LHS, minus 2, 0, 0, minus 2. Now on the other hand, find out the adjoint of A into A. Now, RHS. What is RHS? RHS is adjoint of A into matrix A. What is adjoint of A? Adjoint of A is 4 minus 2, minus 3, 1 into, what is matrix A? 1, 2, 3, 4. Now, this is also same matrix multiplication. First row, first column, second column. So, 4 ones are 4. Minus 2 3s are 6. Again same row, second column, 4 2s are 8, minus 2 4s are 8. Then second row, first column, second column. Minus 1 into 3 is minus 3, plus 1 into 3 is 3. Minus 3 into 2 is 6, plus 1 4s are 4. So what is this equal to? 4 minus 6 is minus 2, 8 minus 8 is 0, minus 3 plus 3 is 0, minus 6 plus 4 is equal to minus 2. Equation number 2. Now what is say? Minus 2, 0, 0, minus 2, minus 2, 0, 0, minus 2. LHS is equal to RHS. From 1 and 2. From 1 and 2. LHS is equal to RHS. What do you say? LHS is equal to RHS. So, therefore, A into adjoint of A is equal to adjoint of A into A are equal. Any matrix into adjoint. Any matrix and its adjoint or adjoint and the matrix are all equal, and they are equal to, there is one more relation, that is A into adjoint of A is always equal to adjoint of A into matrix A is always equal to determinant of A into I. Determinant of A into I. So once if you want, you can find out the determinant of this. So the determinant of the matrix is determinant of 1, 2, 3, 4. 1, 2, 3, 4 is 4 ones are 4 minus 6 is equal to minus 2. See here, if you take minus 2 common factor, 1, 0, 0, 1. What is this equal to? Minus 2 into I. So, what is minus 2? Minus 2 is nothing but determinant of A into I. So, a matrix into its own adjoint, a matrix and its adjoint, or adjoint and the matrix is always equal to determinant of A into I. This is very, very important property indeed. Hope you got an idea. Very important problem for 7 marks. Now, let us take a similar problem. So, that is I will do that property here. Show that A into adjoint of A is equal to adjoint of A into A is equal to determinant of A into I. Same, let me check this. Same problem. So, as I did in the previous itself, adjoint of A is equal to, you know, the adjoint of A is 4, 1 and interchanging the diagonals, right. Then multiply it, LHS. LHS is A into adjoint of A, that is what we got, A into adjoint of A, the same problem, 1, 2, 3, 4, 1, 2, 3, 4. What we got, LHS, minus 2, 0 from the previous one, that is A. A is 1, 2, 3, 4. Again, this is 4, minus 2, minus 3, 1. So, if you simplify the same previous problem, let me simplify once again. Plus 4, 4 ones are 4, minus 6, again minus 2, plus 2, again 3 4s are 12, minus 12, 3 2s are 6 plus 4. That's equal to minus 2, 0, 0, minus 2. So, you can take minus 2 out, then what you will get 1, 0, 0, 1. Okay. Since what is the adjoint of A? Adjoint of A is 1, 2, 3, 4. So, 4 ones are 4, minus 6 is minus 2. Adjoint of A is minus 2. So, you can write this minus 2 as adjoint of A into I. Similarly, on the other hand, RHS, what is RHS? Adjoint of A into A. Adjoint of A, what is adjoint of A? 4 minus 2, minus 3 and 1, and determinant and matrix A is 1, 2, 3, 4. If you simplify, you will get minus 2, 0, minus 2. This is again nothing but minus 2 into 1, 0, 0, 1. This is minus 2 into an identity matrix. What is this minus 2? Adjoint of A is minus 2. So, this is determinant of A is minus 2. So, determinant of A into I. So, what do you say from these two? So, therefore, we can say that from 1 and 2, this is, let me represent this as equation number 2 and this is equation number 1. So, from 1 and 2, we can say A matrix into its adjoint is always equal to adjoint of a matrix into matrix is equal to determinant of A into I. That's it. A matrix into adjoint or adjoint of A into matrix A is equal to determinant of A into I. That's it. This is very important property. You may expect this type of question for 7 or 8 marks. Hope you got an idea how to find the adjoint of a square matrix of order 2 rows 2 column and 3 rows 3 column. That's all regarding this session. Let us meet with the different concept in the next session. Thank you very much.